So this is our project, our laser rangefinder. Right here, this is our first Y servo that changes the height of the proximity sensor. Then this is the second servo that rotates the entire setup about the x-axis. This is our LED, which that's our LED which blinks when an object is in front of it. This is our proximity sensor. This entire module. This is an infrared LED which sends out the infrared light. It hits an object and strikes a photodiode, which then measures the distance in binary. And this right here is our green reference laser, which has a really far-reaching light. Okay, and of course this is our Arduino Uno, our microprocessor, the brain of the operations. Is connected to the computer where we run our codes. Basically we have 3 codes. There are 2 setups. One is the proximity finder, where is a rangefinder, sorry, where objects are kept at certain distance from the setup, and when the setup detects the closest object, it stops and it points the reference laser. And the second is the radar, which keeps the setup rotating, and when an object comes in the proximity of the radar, it stops and the LED glows. And also the y-axis is used to change the height. So now I'll change the height of the laser. See, right now it's on 100 degrees. I can change, it's at this height. I can change the height by changing the code. Change it to 90, running the code, and now we'll move it to 90 degrees. Yeah. Now we run our first code, that is the proximity sensor. We upload the code, and then we'll get the planks. Get the planks.
Distance code.
Yeah, distance code. So keep different objects at different distances. Get something. What about the cardboard? Keep different objects different distances, no?
Mineral bottle.
Okay. One limitation of this setup is that black objects like these, they absorb infrared light, so it cannot detect black objects. So right now I'm going to run the distance code. Yeah. And now the setup rotates. Detecting, the servo can rotate about 180 degrees, so it detects all the objects in the range of 180 degrees. And now, 1 second, stand. Now when the setup locks onto the closest object, it turns and it points the reference laser to that object. Now change the setup. This is how it starts. Since this is the closest object, the laser is detected and it points it towards it. We change the height now. Now since we have the Y servo, we can modulate the height of the entire setup. 60 lower, make it higher, na? Make it higher. 150.
No, 60 is high.
Okay, 160. This is the highest, huh? 160 is the highest? 60. Why it's so low? Okay, like that it is. So now our entire setup is pointing to a different height. Keep different objects at different. Hold one. Keep it far. Fine. In that range. Okay, see now, as you can say, keep it farther, right? Put off the light now. Put off the lights. Once, since it's an infrared since the photodiode detects infrared lights, the setup works with the maximum range and maximum efficiency under lower light. Okay, keep it a bit back. Yeah, run the code. And now detecting the closest object, the laser rangefinder points a reference laser at it. What about the farther object? Just leave everything, put at the farthest object. Come closer, come slightly closer. Okay, I'm going to reset the code now. Why is it coming to that side? Why is it coming to the side?
Because it detected this as the closest point. So when it's coming back here, it'll
Oh, okay. So next, just keep it like this now then. Okay, I'm going to. So now I'm going to reset the code. So now the proximity sensor detects the closest point on any object. Now, irrespective of how the object is, irrespective of how big the object is, the closest point of the object, which is closest to the sensor, will be detected, and hence the reference laser will be pointed on it. Okay, fine. I'll keep it a bit farther. No? Oh, change the side. Huh? Oh, okay, light, fine. Okay, the reference laser is pointing there right now. Good back. Now, since that was the closest point, the rangefinder moves and projects the point of that object. Now we'll change the degree to a lower angle, the vice over, or a higher angle.
Go.
Okay, and now put some objects. What, 90 degrees?
120.
120. Okay, put some objects. Now the laser is angled at a higher angle, points the objects to lower objects. Now put some smaller objects. No? Now show the black one. How it can't be detected. Maybe detected. Okay. Let's see. It's okay. If it detects it, then it's good. No, smaller objects. We took such a small angle for small objects. Oh, let this be the closest. Give me. Bye. Okay, run the code. Oh, okay. So now the infrared rangefinder is indiscriminate to any object. So even an object as thin as the wire could be detected, and also, oh no, I think this was actually farther. Keep it a bit closer. Run the code again. I'll run. Oh wow. Okay, that's good. Well, for certain black objects, the rangefinder cannot detect them, as infrared light is absorbed by darker objects, but in this case it's not so. Okay, now we have the second code, which is our radar, where we make the setup act as a radar. So basically, while running this code, the rangefinder keeps rotating about the 180 degree axis, and as soon as an object enters into this range, the LED stops, and the entire setup, the servo stops, and the LED starts glowing. Run the code. Wait. Let it rotate. Now there's a 4-second delay after it detects an object. The entire setup will keep rotating like this. It's like a sentry mode. Will keep rotating until an object finally gets in to its path, and then it'll come in. Now, as soon as an object comes within its range, it will stop for 4 seconds until the object moves out, and then it'll go back into sentry mode, and the LED starts glowing. Look at it from the front. Wait, move. Leave. It's fine. Go back. I'll come in. Yeah, this is how it works. Very cool. Now, if we had little lower light, if the window was covered, it would work. It would work more efficiently. It would deeply increase the range. But yeah, so this is our project. Our breadboard, Arduino wires, jumper cable, Indranil, our awesome coder. Nice man, nice. What else you want to show? Anything else?
No.
For this?
No.
Okay, that's it.